Exterior CI, or continuous insulation. Here's R5, and I took these pictures when I think it was Certainty, no, Owens Corning was, I'm going to close that door. Owens Corning did a little class on a house that was being built, and they showed how they recommend installing this. And you'll see that they taped all the seams, and they use like roofing nails, you know, the dry-in nails, the plastic head nails to hold it on. And they had built out a 2x2 to nail the flanges on the windows to. Notice that the tape is approved. And so if anybody's trying this and you decide you want to give it a try, make sure you use a tape approved for it, because different tapes expand at different rates. When I started doing my house, I used polyiso, and I just thought, well, I've got Tyvek tape. You know, I bought some Tyvek tape to go with Tyvek, and so I taped some seams. And before I got it covered, I was getting some cracking in the tape, and it's because that tape had bonded real good to the foil on the polyiso, but the polyiso expanded at a different rate, and so it split the tape. And so you just need to make sure you have a tape that the manufacturer of the material or that has a listing that it will expand and contract as the materials do. Because why are we taping? Because we're trying to create that air barrier. The other thing, anytime you do, and I don't have a slide in here, anytime you do multiple layers of foam of continuous insulation, you're supposed to stagger your seams so you don't land seams on top of each other, which is common sense thing. So continuous insulation penetrated by a fastener opener only, approved tape, and I just explained that. It serves as an air barrier and your weather barrier. So just to comment on that, you have multiple building papers that you can put on the exterior. Some of them are an air barrier and a weather barrier or rain screen. Some of them are just one or the other. Tyvek and a couple others accomplish both. But if you take a piece of Tyvek and some of the other products, and you let them pool, you make a pool and let water sit on it, it will take a long time for the water to get through. It will eventually drip because it isn't a vapor barrier. But some of the others that are just so rain will flow down, have perforated holes in them, and the moisture goes through them rapidly, and they leak air. And so what we want it to do is, if it's an air barrier and a weather barrier, we need it to accomplish both. So you got to make sure you're using the right product. This photo, and this is the same house they put the foam on the exterior, but they had a covered porch, and so they did have a high heel on the truss because the truss continued out over the porch. But they had put an insulation dam here, but they hadn't put an insulation dam on this side. So it's something that you need to pay attention to. So we can keep the insulation, in place. And you can't see it very good, but they put foam in the extra space in the headers. And that's something that the insulation table tells you need to do. If you choose that instead of lower door testing. We'll talk about that more in just a minute. Insulation dam, insulating in the corners. This corner is framed so you can't get insulation in the corners. Here we go. You can see that they put foam in that extra space there. Ladder blocking so that you get insulation back in there. I don't think you're in here, but I went out and did an inspection on a home, and it was 10-foot ceilings at every place an interior wall intersected with the outside wall. The framer had put a stud on either side so you had backing. Well, that's great, but we had, I think, 17, it was a fairly nice sized house, 17 places that we had a stud, and then the stud for the interior wall. And so we had a 4-inch, 3.5 to 4-inch space that you couldn't get insulation into, right? And I called it, and I said, well, figure out the area. So 4 inches by 10 feet, 17 times. That's a big chunk of wall with no insulation. And we might think, oh, it's just a little bit. Do you want that on your house? You want, 4 or 5 feet of wall that doesn't have any insulation in it? I don't think so. Basement blankets per the res check or whatever compliance option you use. And ducts in attics, and we've already talked about this quite a bit, so we'll move through pretty quick. But I have seen some of them. DOE says that we have 10 to 45% thermal losses because we put ducts in attics. In our hot climates where we get a lot of sun and our attics get hot, it's more at the upper end of that, and it stays. Sometimes it's even worse. I've seen them at 50% of the load. It's to overcome that load. So burying up in the insulation really helps. If we can get it inside the envelope, it's even better. So the 2018 code, which we did not adopt, actually talks about this and has recognized the value of burying it in the insulation. And we can see the diagram on the upper right, and they are giving us a couple of options, and they have what's partially buried where the top's exposed, and then fully buried where the insulation comes right to the top of the duct, and then deeply buried where you completely bury it. It takes effort on the HVAC guy's part to make sure he installs the ductwork so it's down low. If you're in a humid climate, they recommend you encapsulate the duct with spray foam, so spray an inch on the whole thing. And that is because in humid climates, it's hard to keep the vapor barrier, intact. It gets snagged, it gets ripped or torn, and then we got the moisture problems with it. It's going to be a little bit expensive, but over the life of the house, how much money do you save if you have a well-insulated, airtight duct? The other thing the spray foam does is it seals the duct completely. How much duct leakage do you want in your house? How much of the air that you just paid for heat or cool you want to leak out in your attic and be gone? Every time you leak 100 CFM out of your attic, 100 CFM has to leak back into the house to replace it. And then you have to heat or cool it. And this is what the 18 code says. Prior to 18, it wasn't prohibited to bury the ducts, but it wasn't defined as a practice. And so we've actually put it in the 18 code to encourage it, because we literally had a lot of inspectors saying, well, if we do this, if we bury the duct down in the insulation and our insulation requirements are 49, we're not going to have our 49 for this little area right here. It's negligible. It's really not that much. And really what they're failing to account for is how this is cold air in the summertime. And we want to do anything we can to increase the insulation on that. So we deeply bury it. I mean, if someone's really concerned about it, pay your insulation guy to put a little more insulation in there, and make sure you bury it so you do have the 49 or the 38. And so what this is basically just telling us is that they're recognizing the need to bury it in the duct and how we can get credit for it in our. So I put in I put together a calculation here, and I'm not going to go through every step of the calculation, but if we take a piece of 6-inch flex, 25 feet long, what I want to do is know how much surface area is exposed to the hot attic. And so I did the calculation based on the outside diameter of the flex. And so the circumference is 1.5 feet going all the way around there, multiplied it by the length. So I have 39 square feet of exposed duct hanging up there in the attic for every length of 25-foot length of 6-inch flex. And then I did a heat loss calculation on that with a 145-degree attic, and that one piece of duct is almost 500 BTUs of heat gain in the summertime. Just that one piece of duct. And how much duct do we have in a whole attic system? We have a lot more. So the area of a 25-foot length of 6 inches, 439, but if we have a 20-inch flex up there, we have 1,474 square feet of exposed area where we have heat gain coming from the attic into the duct. Or in the wintertime, it's heat loss from inside the duct to the cold attic. You know, this is the same formula I use on a wall. I take every square foot, I identify how many square feet of wall area I have. I take the U factor, the temperature difference, and I come up with amount of heat that flows through every square foot. So I've done the same thing here. So my point I'm trying to make is when we have all this exposed in the attic, we can add thousands and thousands and thousands of BTUs. And in many cases, we're adding tens of thousands of BTUs of load to our system because we're exposing it to that hot attic. So I've received a lot of questions on this, and I've kind of been concerned with it. I ended up getting a thermal camera, so I was able to see a little bit better how ducts in garages work and how well insulation worked on them. And then talking with some of my friends from across the country that I do code work with, and we came up with what we think is a pretty good solution. I don't know how much you're encountering in a situation like this, but if you have a 2-story home or a bonus room over a garage, you end up with some ductwork in your garage serving that upper level. And I'm sure you're seeing it in some cases. And so here we have these different soffits or fur downs. And how do we insulate those garages? Well, we can come in and do what? Put bats and fill all these spaces with bats, right? And we bat the floor system. And we say, well, the ductwork's above the bat, so it's probably going to be okay. But we have these 2x4s or 2x6s laying flat, and there's no insulation on top of them. We have the face of this drop. Are we getting a piece of bat up inside there? And so what do we have? We think about that. We kind of have a thermal envelope with the insulation, but we really don't. What's the other concern with that? If we have a lot of open air spaces, then we have convective flows, and we have air moving back and forth within our insulation. If we're going to bat this application, do it with bat insulation, I think the only way you're going to effectively meet the code and conserve the heat or the cooling is to insulate the ducts first, and then do your bat. Now that's a pain, And so we've looked at this, and this builder that built this house, this is what he's started doing on all of his rooms over his garages. And he was getting lots of complaints with his rooms over his garages. The air wasn't warm coming out of the registers because the duct was in a space that was semi-conditioned, maybe not fully conditioned. It was cooler coming out in the winter time. It was warmer coming out in the summertime. And so he started doing this for his systems, his garage ceilings. So what does this do? It fills the whole cavity. It fills the joists around the pipes. It eliminates the air spaces, creates an insulation that is enclosed on all sides. We don't have any airflow through it. And his problems with cold floors and uncomfortable garage, the bonus rooms above the garage just about went away. Now, I'm sure that costs a little bit more. The insulation guy back here, I assume you do some div, vent, low stuff, is that correct? How much more, I'm not putting a perfect number, how much more would it cost to vent and blow that garage ceiling rather than trying to back?
Need more bath, cost a lot of money, so not very much.
Yeah. And is vent and blow on a wall a lot more money than on just regular wall or that, or is it a bit more? Okay. I assume you believe it's a better system. I mean, you're going to get every little boy.
Depends on the installer, too. You can blow it in.
Yeah.
Yeah.
I didn't think I brought it up because I went to one up in Syracuse or something like that where the guy that built the installation, he went through and showed us examples of good wool and all the way up to the high density and how it can tell how dense it was and everything. So I'm not saying that net blow solves all the problems because the guy that installs it has to be just as confident as the guy that does a good backup. So I have another comment.
I was just gonna ask Scott, when you blow a wall with that type of material, what's your diameter? Isn't it up around 22?
Depends on which material, big plane you get at 23. There's always things on how dense.
You have to know what you're doing.
He does.
Yeah.
We hope.
Well, you guys kind of chuckle, but I'm sure I'm speaking for most of the inspectors in here, that you know, you recognize builders that are doing a good job and subcontractors doing a good job, and you recognize some of those who don't quite as good a job. And I'll be honest, I was relieved going through some inspections for some builders, and I was kind of, oh, crap, I really have to go there because it was going to be a long list, and I was going to have some pushback on some of this stuff.
You'd have to know, Scott, and I've known each other how long, 20 years? We've had a lot of conversations.
Who do I feel sorry for?
No, usually agree.
Anyway, this system is trying to insulate ducts with your insulation package. Either wrap the duct or you make sure it's completely encapsulated in the duct. I mean, in the insulation. Okay? This is a hard one, and it's a hard one for everybody. And I'm just going to load these up real quick. And those that I know real well in Salt Lake area and in other parts of the state know that I have a strong desire, even a passion, to see load calculations and duct designs done in accordance with these standards. And the reason I do is because I know it works, because that's what I was taught, and I did for years and years and years and years. And the better job we did on our load calculation, our duct design, the better our systems worked. Now, that being said, just because you do a load calculation and a duct design through Right Software Elite or some other software doesn't mean your system's not going to have some issues. I received some calls from, there's companies that's all they do is load calculations. I received a call from the guy and he said, you know what, I did this load calculation, I did a really good one, and they installed the system and they did a pretty good job. But the mother-in-law apartment that they have on this house is always uncomfortable. So what they had done is they built a house that had the major part of the living space on one end of the house, and then they had a hallway that went behind the garage, and then they had a little apartment for mom down on the other end of the garage. And they did a load calculation and they sized their ducts based on what it said. But what they did not recognize is that that should have had two systems, right? You put a thermostat in the main living area where the mom and dad and the grandkids are, and then grandma's down at the other end and she doesn't have a thermostat, and she sees the sun different every day because the sun strikes the main house one part of the day and hers another time of the day. You can do the very best load calculation in the world. It doesn't solve anything, but it will tell you that you have a diversity problem and that you either need to zone the system or you need to put two separate systems. And so I'm not here to say that this fixes everything. You still have to follow the other building science requirements and, that you need to consider when you install an HVAC system. You have to look at how the building's going to be lived in. You have to look at how the sun strikes it. You have to look at the exposures and all those things. If you insulate it well, you're going to have a more comfortable building no matter what. If it's insulated poorly, we're going to have the heat loss and we're going to have discomfort. But you can't expect to do stuff that doesn't follow the science and the engineering that we have for these systems. I had some rules that I kind of put in place when builders brought me plans. If they were approaching 2,000 square feet or bigger, I said we need to start looking at zoning or two separate systems, because we're not going to see the same conditions throughout the house. When you have two stories trying to do multiple levels, you can have the best system in the world, but the conditions change all the time. So, but this is a starting point. And the goal is to have a system big enough for comfort, but no bigger. I think we probably got to talk just a little bit about this a little further, because I'm sure there's people in here that are of the opinion that bigger is better when it comes to a furnace, and I'm going to disagree with you. Now, let me explain one of the analogies that I like to use for this. Back when, and there's still vehicles this way, but back my first cars that I owned, they had a heating system only. They didn't even have cooling on them. But if you were to drive from Salt Lake City to here in the middle of the winter, would you get in your vehicle, turn it on high fan, high heat, and drive until it got warm in your vehicle, then shut it off? And then when it got cold, turn it back on. And then when it got warm, you turned it off and just turn the system on and off. How comfortable would that be? Horribly uncomfortable, wouldn't it? So with that vehicle that doesn't have thermostats that automatically turn on and off, I've been married 48 years, and I learned about 20 years ago that I had to have a vehicle that had a temperature selector for my side and a temperature selector for the other side. and a much happier life. But what most vehicles, years ago didn't have that. It was on or off. Well, that's how our typical home heating and cooling system works. It's on or off. The ideal perfect system would be one that mimics what we try to do with that vehicle. Because as you were driving from Salt Lake to here, once you got your vehicle warm, what did you do? You turned the fan down and you turned the heat down, and then you filled with it just a little bit and you tried to get that sweet spot, correct? And at that sweet spot, you didn't have to touch it because you were adding heat to the cab of your vehicle at the exact same rate that you're losing heat. So the perfect home system or commercial building system would be one that every zone has a thermostat that senses the temperature and senses as it changes a little bit, that increases the heat or decreases the heat or increases the cooling, so that we just add heat or remove heat at the exact same rate, that we gain it in the summer or we lose it in the winter. Now that's the ideal system. Does that make sense? And some of these little mini splits and multi-zone mini splits, they do that. They modulate. They have inverters in them, and they ramp up and down so that you're just gradually add a little bit of cooling or gradually add a little bit of heat, and they're very comfortable. So if we're doing a single or two-stage furnace and air conditioner, the best thing we can do is size our system so that when we're in the cold parts of the winter, the hot parts of the summer, that our system runs almost all the time on those very worst conditions. And then all the rest of the time, it's going to be oversized. Now, I'm not saying we want a system that's so small that if we have a power outage, we're never going to heat our house back up. So we have to have a little bit of recovery capacity and everything in there. But that's not a problem, because if I do a load calculation and I tell you that the load is 21,340 BTUs, you call your furnace supplier and say, I want a 21,341 BTU furnace. No, you can call them up and say, I need a 40 or a 60,000 BTU furnace, right? So you just buy the next size that's available. So you always have some extra capacity, and all this worrying that, oh, it's going to be too small, it's going to be too small. That's unfounded. The other thing is, I know some of you guys have done this stuff for 20 and 30 years, but in that 20 and 30 years, remember our ERI path? The 2006 home has a score of 100. A home built today to the current code is around the 60, 64, 65. So it's already 35% better in that period of time, which means we have improved our insulation and air sealing by 35%. So we don't need the same furnace that we put in 14 years ago, 15 years ago. And if we grossly oversize, it's on and off, on and off. And we don't have the comfort because it's drafty and cold in the in-between time. And your customer will say, oh, but it's going to run all the time. It's cheaper for a small furnace and small air conditioner to run all the time than it is a bigger one to cycle on and off. Just like it's more efficient for me to drive here without stopping at a steady speed, or I could start and stop a whole bunch of times and still get here in the same amount of time if I did what? Went real fast in the time that I was moving. So it's the same type of thing that we're looking at. With that, our biggest problem in our HVAC systems is not that our load is off, even though the loads aren't perfect. Our very biggest problem is our duct systems. I don't have a bunch of slides in here, but I mentioned that I do some expert witness work, and every HVAC system that I've been involved in that had serious problems had serious airflow delivery problems. The duct system was not designed correctly. It had too many sharp corners, too much turbulence, and too much reliance on fan horsepower to shove air through a bad duct system rather than build a duct system that flows air, without turbulence. So just a couple other things that we're going to jump through. And some of this is for inspectors and some of it is for you contractors, but you submit a plan, you do a load calculation, you identify what equipment you're supposed to put in there. So we have a complete set of plans, but then you get out there and do an inspection and you don't know what size the furnace is. And you can't read this label very good. I need to change the contrast on that. But if you're inspecting against load calculation, you probably ought to verify that it's the right equipment. And someone says, well, it's hard to get into it. Well, Harbor Freight sells this screwdriver for 99 cents. It has a nut driver and screwdriver and everything else on it, so you can get into your furnace and check that out. And if your jurisdiction won't buy you $1 screwdriver, give me a call. I'll send you a buck. Or next time I'll bring some screwdrivers. Mechanical system piping. When I say mechanical system piping, what am I talking about? I'm not talking about your hot water that you shave and everything. With, I'm talking about hot water that we might do what with. Or it's not necessarily hot water. We heat the home. A radiant floor, we talked about radiant floor a minute ago. What other mechanical piping?
Snow melt.
Snow melt? We're missing another one that doesn't necessarily use water. Refrigerant lines. We have refrigerant lines. And so we have some requirements in here that if the temperature of the fluid or whatever's in the line, and by the way, gases and liquids are considered fluids. If we're not in this range, we need to insulate to R3. So our refrigerant lines, the small little copper line is typically in this range, and so we don't insulate it. But the suction line, the bigger line, is cooler than this range, and so we do insulate it. Now, why do we want to insulate cooler lines? So they don't condensate and drip and give us mold problems. And of course, we want to insulate hotter lines because if we're doing a radiant floor system and we have all that piping in the mechanical area, we really need to insulate the piping, the distribution piping that's getting it there, and just radiate the heat off the tubing that's in the floor or at a radiator or whatever we're at. And so that's even a smaller amount of insulation, but that's effective. Circulation loops. Do we see those very often? Someone builds a nice big home, they put a return line on it to the water heater, put a little pump on it with a little check valve and a timer on the pump so that if during the day when you're going to be using hot water all the time, that the pump circulates and keeps hot water out close to all the fixtures, so you're not wasting a bunch of water and you have hot water fairly soon. Did you know that loop, that whole loop is supposed to be insulated? And so many homes I went and did final inspection, and there's the little pump, there was a return line. I didn't realize it when I did rough inspection, and the house is all finished. I never made anybody tear it all apart to do it, but if we're going to put recirc on them, you need to insulate the loop. That way it holds the water in there, it holds it hot, and so here's a recirculation loop, and I took this picture in a house, and actually it's done wrong, and I don't know how well you can see it. Well, they have the hot water heater. Here's the cold supply in, coming into the water heater. Here's our expansion tank. Here's our return line coming back. So when this pump runs, it runs hot water out through the whole loop and then returns back and it goes down the dip tube on the water heater, and we just maintain hot water. But they put the pump in the wrong place. they put it right in the main hot water line. The pump needs to be over here. So it's just pulling it through that loop. Because as it was installed, all the hot water in the whole house that's being used is running through the pump, whether the pump's running or not. And so you're gonna have drop or loss, pressure drop, trying to run past the impeller in the pump.
Also, another point on that one, if you're doing them right, you got a temperature sensor, and that you turn to, it'll turn the pump on in addition to the timer, so it's not running all the time. So just, you know, when the water cools at that point, you recirculate.
Yeah.
It won't do it there.
Yeah. So it's insulate the loop, have a timer that you can set so you don't maintain it all night long, and a temperature control so that we just shut off if we're to temperature. We don't need to keep recirculating, get it up close to temperature and then let it set and rest. But that doesn't work unless you insulate it so that it holds the heat in the line. Installed per the manufacturer's instructions. I haven't beat on this one today like I do with some of the mechanical classes I do, but if someone in here wanted to propose a code change, and say one of you decided, you know what, Brent, we need to fix something in the code, this is broken. You know, you got an idea, let's fix it. If you wanted to fix something in the energy code or the mechanical code, what's the first code that we could get the change into the printed code? What's the soonest we could get it in the code?
That if you need to get it in the 24, would be one after that.
The 24 is basically in progress and you're too late. Actually, you do have a month and a half, you could get it in some of the code. If you proposed it in by January 7th or something like that, you could get some of the energy codes in there. But for all intents and purposes, we're too late for the 24 code. Half the 24 code's already done. So we're looking at the 27 code, which the very soonest anybody's going to be adopting it is 28, maybe 29. Do we know exactly how you're going to be building a house in 2028, 2029? No. Are we going to have materials that are different? Are we going to have HVAC stuff that's materials or systems that are different? I mean, look at variable refrigerant flow in some of these systems, how different it is than it was 7 or 8 years ago. And can the code include direction on everything? No. And so we have to rely on the manufacturer's installation instructions, which I did a search. You know, I have all the codes in PDF, and so I can do Control F and search for a word. I searched for manufacturer's installation instructions. Guess how many times it's mentioned in the I codes? You want to take a stab? 721 times. Manufacturer's installation instructions are code. There's requirements that those instructions are on site for the inspections, that they remain with the equipment because the manufacturer produces a product, takes it to a listing laboratory, has it tested in accordance with specific instructions, and then it receives a listing. If you don't install it in accordance with the instructions, you're not installing it in accordance with the listing, and you're violating the UL listing or whatever listing on that product, and they won't guarantee it, and and it's not going to be safe or not going to be effective. And so the manufacturer's instructions are very important. In fact, I reference the manufacturer's instructions many times in inspections. Rather than go out and see an air conditioner sitting underneath a deck where it's just going to recirculate the heat and build up and get hotter and hotter, I didn't write down, you dumb SOB, you can't put an air conditioner under a deck. I'd simply write, please refer to manufacturer's instructions and show that you can install that air conditioner with only 1.5 foot of clearance above the air conditioner. And they go and get the instructions, and guess what it says? 8 feet, right? So we need to refer to them. There's a reason. I used to get so frustrated with employees that would call me up and say, hey, train changed this furnace. It's a little bit different than the last model. What do I have to do? Well, you got the instructions, dude, right? It's right there. Open it up, read it. So that's one of the places that hot water pipes need to be insulated. And what I'm talking here is water heating for, for our potable water. This is the list that's in the code. By state amendment, they've said that you don't have to insulate the hot water pipes under the slab, which I disagree with, but that's what the legislature did because some plumbers complained that it was expensive to do it. But what happens if you don't insulate it and have the pipe buried in a concrete pad?
Just heats the slab. Actually, it could be a problem if you have water more than 140 degrees too, which normally wouldn't be.
The problem is, if you have it in a clay soil or in concrete, it loses the heat so fast. And so every time someone uses the hot water, St. George, they put lots of slab on grade and they just run all this PEX all over in the slab. And every time you turn on a fixture anywhere in the place, you have to clear the pipe all the way to get some hot water to it. Even if it's only been off for 5 or 10 minutes, because when you have that solid contact with a solid material, it sucks the heat up a lot quicker than the air around it. If I have my hand in 32-degree air, my hand gets so cold. Put your hand in 32-degree water, how fast does your hand get cold? Seconds, right? That I can't take it anymore. I used to think I was pretty tough and I could keep my hand in cold water for a long time. Yeah, not anymore. I think it's arthritis and crap in my joints, right? Someone mentioned snow melt. You guys do some snow melt out here, I'm going to assume.
It's the rich folk.
Yep. My house faces north. I'm thinking real serious about it.
Yeah.
Especially my front porch. For 2 or 3 code cycles now, it's, we already talked about J&D. If you use a snow melt system, you have to put a sensor in it now. For a lot of years, we didn't have that in the code, and people would say, well, I got a timer, or I got a switch, and if it's going to snow that night, I watch the weather, I turn it on, and then it doesn't snow, and the driveway gets warm, and it just keeps getting warmer and warmer and warmer, and it's really wasteful when we get in that type of situation. So if you have enough money to put in a snow melt system, you need to spend a little bit of that and put in a control that's going to cost you another $1,000. And what it does, it senses slab temperature, it senses air temperature, and it senses moisture. And it cuts the system off when it's not needed, and it turns it on when it's needed. I put in a number of these things, and they work really slick. And then pools and in-ground spas. We have a couple of things. Ready access to shut-off switches for heaters and timers for pumps and heaters, and vapor retarder covers for all the pools, and covers if heated. They tried in the code to put in that you had to have a R3 cover or something like that, but how do you put that thick of blanket on a reel? And it's just, it doesn't work. So this pool, that is my neighbor's pool. It has an automatic pool cover that you just hit a switch and that covers it, and it's, reduces your heat loss. So you're not running your boiler quite so much. And there's some exceptions in that. You don't have to do it if you're using some solar to heat your water, or if you're using waste heat or something like that. So a couple of things. that I like to mention that we should be paying attention to at final. This could be for you builders that you check before final inspection, or you call for it, or if you're doing a final inspection. Everything's supposed to have a programmable thermostat. Now, I'm not crazy, but you're not going to save a huge amount of money with the programmable thermostat, especially if you have an efficient envelope. Where they save money is when you have a crappy envelope, because you're shutting down a system that uses a lot of energy. But that being said, the code requires it. Those either in HVAC, you know what I mean by this, heat pumps. If they're using electric supplementary heat or a heat strip that kicks on when you crank the thermostat up, you need an outdoor stat that keeps the strips off if it's warm enough outside to heat your space. Hot water boilers need a reset control that changes the temperature of your boiler water as the temperature varies outside. Snow melt systems, what I talked about, they need to rough in for the cup before you pour. Pools we just talked about, and at final, 75% of your light bulbs are supposed to be high efficacy. This really isn't a big deal anymore because LED is finally reasonably priced. You know, when LED first came out, they were terribly expensive. I did a little coffered ceiling in my family room, you know, where I had all this finished trim and little recessed panels that went up. I bought 4 LED lights, little cam lights with dimmers. I paid $35 a light, you know, 10 years ago. Now you can go buy the bulb for what, $1.50? So that one's an easy one. And I don't even think you can buy incandescents that easily anymore. And I don't know how many people like CFLs, but I don't like CFLs, so I just buy LEDs. Okay. We didn't make it through that part by lunchtime, but that's okay because we can get through this part a little quicker. And we've touched on some of this, so we don't have to spend quite as much time on it. Remember I mentioned that we have 5 options to comply with the code, and then I said we have some mandatory things that we have to do no matter which option we choose. And the first thing is we have to address air leakage. And what it says on your handout there, we have 402.4, it talks about air leakage. And we have the building thermal envelope by amendment either complies with this table or it's blower door tested. How many have not seen a blower door test? I'm sure there's some of you that have not seen it. We'll talk a little bit about that in just a minute. What a blower door test is basically is that we pressurize or depressurize the house, simulating wind on all sides of the house, and see how much it leaks. We just measure how much air it takes to maintain a certain pressure. Kind of an analogy that I like to use is, have you ever had a hole in a tire and you put your air compressor on it and you can hold the tire up as long as you keep the compressor on it, right? Well, we take a house and we take it to 50 pascals, which is 0.2 inches of water column, which isn't very much pressure. And we measure how much air we're having to keep putting into it to maintain the house at that pressure. So it's just like, how much air do we have to put in that leaky tire to maintain pressure? And from there, we determine how much the house leaks. So the amendment says, and I mentioned this before, we either blower door test it or we do this whole chart. And I've summarized that chart on this form, and it starts the bottom right-hand corner are the first couple of bullet points, and then it runs on to the next page. And I have 12 or 13 items identified on there. And first one, install the insulation per the manufacturer. Have a continuous air barrier. All the gaps and voids are sealed between conditioned and unconditioned space. Air permeable insulation not used for air sealing, so you don't use fiberglass or rock wool to stop air leakage. Closed cell foam is the only insulation that serves as an air barrier. Drop ceilings, soffits, shafts, chase shall be capped. What am I saying with that? So you build a house, and I'm sure you guys have done this before. You build a house and maybe you have scissor trusses on that house. Do you go into your closets on that house and drywall up and whatever angle is in that and then come back down, or do you go in the closet and drop it off at 8 feet or whatever? We see this all over the place, don't we? We see drops for showers because we don't want to tile up to 8 feet. We might drop the shower to 7 feet. Or, you know, there's lots of places that we drop a ceiling. We have some plumbing or something up in there, so we drop a ceiling. Well, if this is the upper level on a 2-story, or it's a single level house, and if we have these little drops, don't we create kind of a challenge in insulation? So the insulation has to come across and then drop down and then go across and then back up. And it doesn't, they blow the insulation and then the wind is blowing it so it's deeper into the lower thing. And we just have kind of a mess, and we have lots of places for air leakage into the attic. What this table is saying, you need a continuous lid all the way across, right at ceiling height. So any place you put a drop, put a lid in. Now we already do that in chases because we make them block it for draft stocking or fire block at the top of them. So everywhere you block it. And then what happens is you have this nice uniform blanket of insulation all the way across. You can seal it better. Every time we do all this drop and back up and everything, we just create this little mess that's just, is not really good practices. And so that's what this table says. Without amendments, we do everything in the table and a blower door test. With the amendment, you can choose, oh, I'm going to do this table so I don't have to pay someone to do a blower door test. So if you're doing the table, that's one of the things you have to do. This also talks about 6-sided on insulation. Everywhere needs to be 6-sided, including a rim joist. How do you 6-side the insulation in a rim joist? So you have the rim with a piece of insulation against it. You have a floor above. Maybe you have a plate below, maybe you don't. Or the top of the foundation. You have a joist and a joist, but we don't have anything on the face. So how do you put an air barrier on the face of a piece of fiberglass bat that's been tucked into a rim joist? You take a piece of Tyvek and cut it out nice and pretty and staple it all up in there and caulk it around. I don't think so. Or take a piece of OSB or a piece of drywall and cut it out to fit within the eye joist and stick it back in there so you have an air barrier over the insulation. How do you do it? Closed cell foam. The closed cell foam is an air barrier in and of itself. We don't have air moving through it. You know, there's a group in Colorado called Construction Instruction. In fact, they have a really cool app that you can put on your phone. But Mark LaLiberte and Gord Cook and Justin Wilson, these guys are, I call them building science geniuses, because they really understand this stuff. And whenever I participate with anything they're teaching, they always say, builders walk out of here and choose 1 or 2 things, you know, that you're going to do in your homes, and then next year maybe choose another. And usually on their list is number 1, spray foam your rim joist, regardless if your inspector makes you do it or not. And number 2 is put high heel trusses on your homes. And again, it's going to cost you a few more bucks, but just make it your signature, you know, that you're going to do these certain things. But I'm not going to tell you have to do it. I'm suggesting you consider doing some of these things. Mechanical ventilation, whether they make you do it or not, you should be doing that. So there's some of those things. So it's either this or blower door test. And if you're doing this list, you basically have to spray foam in your rim. Now, what you can do in Utah, because of the amendment, is you can say, nope, I don't want a blower door test. and so I'm going to spray foam, or you can say, well, I don't want to spray foam, so I'm going to do the blower door test. And maybe you're not going to pass, and maybe you're going to end up having to spray foam to pass the blower door test. You see what I'm saying? The whole reason this table was written is if you follow this table, you're going to pass your blower door test. Please.
Just one thing, if they follow this other table, they're supposed to document and submit this to the building department that they did all this. Let's just not do it, forget about it. My understanding.
Yeah, very good point. What the code says right at the front is that nothing is supposed to be concealed until it's inspected. Now with this table, they have put in a little caveat that you can work out, if your inspector says, well, you can document, you can take pictures that shows how you insulated the corners, or you insulated the headers, or you did this or that, because he can't come out and inspect every little piece of this in separate, inspections. So yeah, there needs to be a documentation path that shows you comply with all this. Now, to be honest with you, it's probably cheaper just to blower door test the house. But you're gonna have to do some of this stuff, but you just don't have to have it verified. The whole reason the code was written with both in there is because that's really the proper way to build a house that's gonna have fewer problems. It's gonna work better. Garage separations. This is one that we miss a lot. How often do we have the power out someplace in the country? But we just had it happen in Texas this past year. Had this big power outage for a long period of time, and there was, I can't remember how many deaths, but a large portion of the deaths were from what? People running generators in their garage. They cracked the door open and were running the generator, and then they died because they had so much leakage from their garage into their house, they died of carbon monoxide poisoning. They had doors open, but you still had such a high concentration, and we do a crappy job of air sealing our garages. We wrap Tyvek all the way around the outside of our house, including the outside walls of the garage, but we never put it on the inside house garage separation wall, but that's part of the thermal envelope. That's part of what needs to be sealed. And that one should probably be sealed the best because exhaust fumes and all those types of things. Plumbing and wiring, that insulation needs to be cut and fit around every wire, every piece of plumbing, everything. Really, you should be doing these anyway. Electrical boxes all sealed. All your HVAC boots that come out of the ceiling need to be caulked. All your cam lights need to be caulked. All those types of things. So blower door testing. And I'm not going to read through all this, but we talked about this already. Basically, the original amendment required you can leak as much as 5 air changes per hour at 50 pascals. And as we mentioned earlier, there's been an incremental increase, and so you can only leak 3.5 air changes per hour. So it's gotten tighter, with an exception for townhomes. Townhomes can still leak at 5. And that's why, because we don't do the air sealing between the units and we get leakage between units. Without amendments, the trigger for mechanical ventilation is 3. The table's a guide that helps us pass. If you don't want to do the blower door test, make sure you follow the table, including spray foam in the rim joist. And if it's selected, you need to do most of the table to pass. And again, if you're tighter than 3 air changes per hour, you need to mechanically ventilate. We're going to speed that one up here in just a minute. So what a blower door test is, and I probably should put a video in sometime. You might want to, in fact, we have a video of blower door testing on that Utah Energy Code.com website. We recorded a video of how you do a blower door test. You have a canvas adjustable door. You open the front door, you stick this thing in there, and the little clear thing is just so you can see in and out. we have a Magna Helix gauge here, a digital gauge that senses pressure inside and outside the house. And we start this fan up and we turn the speed control on this until we get to 50 pascals, which is less than 1 PSI. It's less than a quarter PSI. But we pressurize or depressurize the house with the fan running, and we adjust the fan speed until it's just kind of sitting there at that steady pressure in the house. You see the two tubes? Maybe if you're close you can. There's a tube that's measuring outside pressure and the inside pressure. And then this device also hooks to the fan and measures how much air is going through the fan. Now, if the house was 100% tight with no leakage, and you sped that fan up to where it was sitting at 50 pascals, how much air would be going through the fan once you reach that steady condition? None, because it's not leaking. We're just using the fan to maintain a pressure inside the house. But because the house will leak no matter what, we're not going to make a perfectly tight house. We are going to have a certain amount of leakage. And so all we do is measure how much air we have to put into the house or pull out of the house to maintain that negative or positive pressure. So that's exactly how it works. And it's kind of slick because most of the time they do negative pressure. So they suck the house down 50 pascals. So it's 50 pascals lower than outside. And so we get the leakage in. And you can take little smoke things or theatrical fog machines, or you can take a thermal camera and you can detect where we have the cold or hot air coming through the wall, around the windows, through the plugs, coming down from above. And so you can measure how much leakage you have, and it helps you find out where you need to fix it. The challenge is this test is usually done after carpet's in. Pretty hard to fix, isn't it, after carpet? So when should we really do the test? Should probably do the test like when drywall's mudded or painted, before you do any floor coverings, because then you'll see where it's coming underneath plates, wherever it's coming, before you blow the attic, so you can see where it's leaking, and so you can address those things. Most builders that do these, after 1 or 2 houses, find out where their weak spots are, and then they just address them, and they don't have a problem passing. It's really a cool system. We've been testing. What else do we test? We test plumbing, we test gas lines, we test a lot of stuff. Why would we not test leakage on our house?
Right. Now, in this, we might want to point out too, you might have already told them, if you have ductwork that's outside the element, this would probably be tested also.
Yep. I do have one. I haven't got to it yet. But yeah, if you have ductwork in the attic, I already complained how much I hate it in the attic. If it's up there, you have to do a separate test on the ductwork to limit how much leakage you have through your ductwork. I'm pretty sure I have a slide in here. So when this was put into the code, it was at 5. January 1 of 2019, we went to 3.5, and then we were supposed to this year go to 3, and we did not. The legislature changed that one, so we crossed it out. And the test needs to be by someone certified to do that. And townhouses and other multifamily still stay at the 5, simply because it's a little bit harder to pass that. Here's the list. We've kind of gone through that already. So here are some of the spots that leak. We have a cantilever, we get leakage here. And of course, we get it around the whole block. This should be sealed off there. We get leakage for sill plates, and such are nailed down on your sheet, and you get leakage even on top of our foundations, even though we do sill seal sometimes. Sometimes that isn't enough. I've seen this demonstration made a couple of times. How big a hole do you want in your house? If you have a house that leaks 5 air changes per hour, we could maybe figure out how big that hole would be if you added up all the little small holes. Do we want a 3 foot by 3 foot hole in our house? Probably not. So the tighter we make it, the smaller that, you know, that total hole is going to be in our house. We really don't want anything in there, or very little in there, and then we want to mechanically maintain our quality. So something that you need to be aware of, if you remove if you remove air from your house, it's going to be replaced with air coming back in. Like I said, we can't make it perfectly tight, and so if we remove a certain amount of air, a like amount has to come in until we get to, and this is kind of an arbitrary number, does 400 CFM mean anything for you inspectors or you builders that build homes and put big range hoods in? The code tells us that if you have a range hood that exhausts more than 400 CFM, you need to provide makeup air. What the code's recognizing that our typical house built to today's standard, not above today's standard, but today's standard, can't leak much more than 400 CFM of replacement air in. You turn on a range hood and you're sucking out the smoke and stuff, you don't pull air out of your house without replacing it. If your house is real tight and you put in that 1000 CFM range hood, it's not going to move 1000 CFM because it can't get the air into the space. If you have a B vent, an 80% furnace, and or a water heater is hooked to, and you have that 400 plus CFM fan in there, where's it going to get air? Down the B vent. And it'll do it all the time. In fact, that's the reason that requirement was put in the code, because we're reversing B vents and all the products combustion from a furnace and water heater are coming into your house rather than going out the B vent.
Used to be in the old days, they put the water heater in the same room as the dryer, and the dryer would do the same.
Yep, and the dryer would do the same thing. You suck because the dryer is 125, 130 CFM fan, and then you put it in an enclosed room with the dryer, the water heater, and it reverses the water heater. Wood burning fireplaces. My first house that I bought back in the early 70s. It was so cool, brand new house, little brick rambler, and it had a masonry fireplace, and you're so excited. Young newlyweds, you put in a big fire in the fireplace and go downstairs, and what's that smell? And the furnace is running, and it's spilling out the front of the diverter, and the water heater's just spilling out. Everything is just being drawn right in your house, all the carbon monoxide from all the products of combustion. So we do get some airflow through the thermal envelope, but not enough to make up for some of those things. But we are going to replace air in and out. You know, whether we pull it out or we push it in, we're going to have leakage to account for that, so it's balanced. There's our gasketed light boxes and cans. As I mentioned before, and here it is, here's a diagram. These are all the places that you should be putting that little gasket tape to stop the leakage. So we do the blower door test. You have a little gauge on here. You run it up to 50 pascals, and this is negative, and it's telling you that you have 3.3 air changes per hour at 50 pascals. I can probably pull that because we already covered it. So let's talk about mechanical ventilation. I've mentioned this a number of times already today. Mechanical ventilation is basically, well, let me back up. I'm going to put out a term, and I don't remember if I put it on here. I don't think I did. Anybody want to take a stab at what infiltration is? If you were to, it's defined in the codes and defined in Manual J, and it's defined all the time. Anybody have any idea how you define it? Be brave. It's the uncontrolled leakage of air in and out of our house or our building. So it's uncontrolled. So what would ventilation be? Controlled, right? So what's the problem with uncontrolled? The number one problem with uncontrolled is we don't get the ventilation exactly where we want it. Where do we want to ventilate moisture out of our house? Bathrooms, maybe laundry rooms, right? Maybe kitchens where we're cooking. Those are the best places to ventilate moisture out of our house, or the sources. So we ventilate at the source. If we just have a leaky wall and that master bath with the jacuzzi tub that bubbling and putting all kinds of moisture in the air, if we don't have a fan ventilating it, does that leakage in and out of the wall throughout the house really do much to that moisture? No, it doesn't. What about when the wind blows really hard? If we have uncontrolled leakage on a leaky house, if the wind blows hard, we are going to have much greater infiltration than if it's still or fairly quiet outside. And I'm sure many of you experience this. You have wind and you can feel drafts in various parts of your house because it's leaking throughout your house. And what it does is it really can make it so your system doesn't work. Every so often, and it's like, maybe you have something similar here, but in the Salt Lake Valley, where I've lived virtually all my life except for military, it's like every 15, 20 years or so, we end up with a real bad cold snap where we drop down to 0 and we just hang out there for a week or 10 days or something like that. And we get these strong winds coming out of Parley's Canyon that are just ripping down out of the canyons that sometimes 10 below 0. And it's not our normal condition, but we get this every so often. And it's outside the normal design parameters that we use on Manual J. But by design, Manual J will work as long as we don't have a lot of uncontrolled infiltration. But if we don't have it controlled, and we have a house that has a cantilever, say the whole east side of the house, and it's facing the canyon, and we have that 10 degree below 0 air coming down and in through the cantilever, the house simply won't heat because we're doing what? We're pushing the heat out of the house quicker than we can heat it back up. And it's just because of the leakage. You have a leak in a gas line, and the more pressure you put in it, the greater the leak. So the bigger the leak, the higher the pressure, it just compounds. So the goal is, and what works the very best, is we minimize the amount of leakage, and then we control how much ventilation. And what do we ventilate to? We ventilate based on the number of people that are in the house and the square footage. And so we have little formulas in the code that tell us how much ventilation we need, and it's really quite a small number. We do it based on bedrooms and square footage, basically. So the typical house, 2 through 4 bedrooms, are going to have someplace between 40 and 70 CFM of ventilation air. And the code says, and ASHRAE, the standards for ventilation and everything, the engineering standards say we need to ventilate continuously, which means the fan runs all the time, or we can do it intermittently and spread it out as much as 1 hour every 4 hours. So if I need 50 CFM of ventilation air continuous, but I don't want to do it continuous, I only want to do it 1 hour every 4 hours, what am I going to need to do? We're going to have to do 200 CFM so that our average over that 4 hour period is 50 CFM per hour. So if we want to just do 1/4 of the time, then we have to do 4 times the rate. Now, is that a bad thing to have a fan running all the time? Now, I'm not a big fan of what we call positive pressure ventilation with a furnace. And here it is with a furnace where we're sucking in a certain amount of outside air. We balance it to the 50 CFM, and we just let that blower run all the time. If you have a good high efficiency blower with an ECM motor and everything, it's not a bad thing to have it running on a low CFM, always filtering, right? And bringing in a little bit of air. But that's a positive pressure system, so what it does is it pushes contaminants into our wall cavities. So it's not my favorite method. The code allows you to do that. So you bring in some air, you positive pressure, and you let it leak out. It complies. The next one is we put a fan, or maybe we do 2 fans that run all the time. And Panasonic makes their Whisper series fan or Whisper Green, and they have a number of different fans. And they are very, very efficient fans. In fact, their current draw on them is similar to the current draw on a doorbell transformer. So it's very, very low. You cannot hear them running. I don't know how many of you have ever put in a Panasonic fan or seen one. You could have been in projects that had them and you wouldn't know it because you can't hear them running. And so what's very popular, some builders are just putting in a Panasonic fan and they will hot wire it so that it's on the breaker and it just runs all the time. You can add controls to it that sense humidity, or you can even add a switch that takes it to a higher speed when you go into the bathroom. To measure humidity, it can sense occupancy, or it can be manually raised to a higher speed, or even a timer that it runs for 15 minutes or 20 minutes when you go into the bathroom. That's a pretty affordable system. The fan's $150, maybe $200 if you add some of the options. Put it in a master bathroom or someplace centrally. Some builders just put them in the central hall and just let them run all the time. And it can leak in the 50 CFM or 70 or whatever the number is and take care of your air quality. The beauty of that is you can put it in a location where you're creating the contaminants. And so you're taking care of those. Again, those can be put on a timer so they run intermittently or they run contiguous. Or you can do the best one, but it's by far the most expensive, and that's a heat or energy recovery ventilator. Anybody ever put one of those in? I'm sure some of you have seen them. They're an exhaust fan and a supply fan in one. So you exhaust air out of your house, run it through a heat exchanger to outside. At the same time, you bring in fresh air that goes through the other passages in the heat exchanger, grabs the heat out of the air you're throwing away to heat or preheat that cold air you're bringing in from outside. And they run 70 to 80% efficient. So they recover quite a bit of that heat. You spent money to heat it up. We're throwing it away so we can grab some of that. This is what we call a balanced ventilation. That's the ideal because we know exactly how much we're sucking out and exactly how much we're putting back in, and we have a more balanced system. The only problem is they're a little bit pricey, especially with ducting and everything. But it's a good system. Whatever the case, if you have any of these or any other fans, the energy code requires that you have dampers that close if the system is not in operation. Just like your dryer vent or your bath fan or your kitchen fan, you have to have a damper that closes when it's not in operation. Why? And it has to be at your air barrier, at your thermal envelope. We can't rely on just the damper in the fan. And those fans have to meet a certain efficacy. I mentioned this fan as being a high efficiency fan. You cannot use that $13 cheap fan for this. Number one, it would drive everybody crazy and no one would ever leave it running. And number two, they would fail in about 3 months of continuous operation if they made it that long. So there's a table, and I don't think I put the table in here, that requires a certain efficiency on the fan. This is not in the energy code, but it ties in with exactly what we were talking about earlier on our walls. And this is in Chapter 8 of the Residential Code. And in Summit and Wasatch County, with all those great big homes that are being built there, and I don't know if you have some of them here, but we have lots of people, the wealthy people that are putting in the snowmelt systems. Do any of them have flat ceilings in their big mountain homes? No, they're all what? TJI rafters, right? They're not even putting scissor trusses on. They're having the maximum height in their ceiling. And so you build a home with TJIs for roof rafters, and then what do? You stuff it full of insulation. And what happens? No ventilated space, and we have the same problem, but worse on the ceilings than we have on the walls, because warm air rises, and that warm air has moisture in it, and so we're driving up by that stack action effect. We're driving the moisture into the underside of that OSB. And I mean, I encountered this as an HVAC contractor in Pine Brook and all those areas of the canyons along there by Park City. They build these great big beautiful homes with the big glulam beams and everything supporting these roof systems. And the wintertime, they'd have water running out and down on the glulam beams, these exposed glulam beams. And we're trying to figure out what the hell's going on. And what's going on is we're condensing on the underside of the OSB, and it's running down and hitting blocks and then runs down out of and the roof's not leaking. You know, they roofers up there time after time after time trying to figure out what's wrong, and it's not leaking. It's condensation because we living in the house. So, and then what does the roofer do when he goes to replace a roof? Every time he goes up and walks around on the roof and he goes, well, we're probably gonna have to replace 10 sheets of OSB because I can feel the sponge, right? Because it's been wet. Now, part of that's because they didn't vent the bath fans outside, or they had ice dams or whatever, but part of it's because we didn't have a vented attic, or we had a poorly vented attic. So this has been in the code now for, I think, 9 years. Maybe it's 6. Climate Zone 6, you need a minimum R25 air impermeable insulation, either on top of the roof sheathing or on the underside of the roof sheathing. And that R25 will maintain a warm enough temperature that we don't ever condense. Now, there's some pretty expensive ways of putting foam on top of a pitched roof. You lay all the foam down there, you put sleepers, you create ventilation air spaces, and there's a whole bunch of details. I can send you some of them. And they work really well, but they requires sheathing your roof twice. You sheath it once, and then you add all the insulation, then you sleeper and sheath it again. Or you spray foam on the underside, 3.5 inches or so to get an R25. And then the rest of the insulation, the rest of the 49, you can blow or bat underneath. There are some products, and maybe you've heard of this, there are some smart membranes that Certainty makes when they call it membrane. And some jurisdictions allow them. I didn't of the county because we had problems with them. And the reason we didn't allow them is because, like, they're a vapor barrier that stops moisture from getting in, but if moisture's inside, they allow it to dry out. So it's supposed to solve the problems of putting a vapor barrier on a ceiling. Problem is the same thing I talked about on the walls. Manufacturer of that product says you have to caulk around the top. You know, you run it down your roof, put a bead of caulk along the top plate, seal it to there, tape all your seams, do everything. So they do all that. And again, the drywall guy comes in, cuts all the holes in it, and the moisture gets through, and we have a roof that still rots away. So this one is a problem. It sometimes takes a number of years before anybody sees it. But that has been, and it's in 806.5 in the IRC. And Climate zone 5, it's R20, and climate zone 6 is 25, and 7, 30, and 35. And that's what it takes to prevent that condensation problem. I think my batteries are getting close to. Do you guys want to take a short break and then we'll wrap it up in about an hour? That work? Okay, let's take a short break. Let's try to get back here in 8 to 10 minutes, and then we'll burn through the last 40 slides. I hear all this groaning when people stand up.
We're old.
We're old, huh?
He was almost.
Right. My whole food. Oh, yeah.
I've watched this scratch. Such a shit. I mean, they was, but when you go on, you see scratches. Is so fun. So she takes me back and says, "Oh yeah, we put very nice back. That's roll with the scratches." Okay, so they send me back to the new one. They said, "Don't use your t-shirt, don't use your hand, don't use this, don't use that. Use this cloth." Okay. My dog. Don't pack that cloth with me everywhere. T-shirt. The other day I forgot to go home. I called her and said, "That one I'll buy." I'm just at the shop today. Bring them up. I had to go meet Trent uptown. I called her and said, "Just take it to work with me and I'll sit by and grab it." I went to go work with you. I said, "What?" She said, "They're like,
Been to the eye doctor. It's going to be no longer.
I went to Walmart and I've been to sites. My first glasses I had was for light rings. Because when I would run the dryer, I would concentrate so hard. It just gave me a headache. Or when I watch TV. So that's what I work. So this time I went to Walmart. Spent $1,000 for a glass. Well, back to sites we go. I paid $1,000 for a pair of glasses. My first one was open.
Yeah.
They're, I don't know what places don't accept them because they meet or exceed warranty. They have some C87 shit. But it's not stamped on the frame or the lens.
No, I will.
I got busted a couple of times. It's just because the guy that busted me, he got busted. Yeah, the same lady caught it, but she knew her shit. She knew that they met or exceeded it, but they wasn't stamped. So she made it. Then hopefully started making one that was stamped. Now, man, it was like $200 more. I went to the area doctor the other day. I've been studying up on all that shit. My right ears, like to sit and have a conversation like this, perfectly fine. But certain tones, shit, my right ear is all. I put in a set of test hearing aids. My wife was several years. She talked to me.
Yeah, mine.
It didn't sound like she was mumbling. That lady's all, what? Oh, that was like, I said, the only word I can think of is clear. So, yeah, that's how it's supposed to be. They come on switch.
Had thermosity,
It's kind of like your eyes. Thanksgiving.
Yeah, I was in the jail for a long time.
I can read it. I do better than hell over here. I do my, this I have a hard time. But like right there, I can read it perfect. There, right there. A little bit. When I do my work on the computer, it's big enough, it's all right, but if I'm there for longer, about 25 minutes.
Okay.
They damn fast when you're playing it, they really suck.
Yeah, I think they're.
Shit ain't where it's supposed to be. It's either away or it's closed. You couldn't try to put a bolt in it. Shit. Yeah. And they're all looking, what's wrong, Mom? I'm blind with them and I'm blind without them. Yeah, but eyes ain't that horrible. My ears are theirs. I see American Case of Labor, Radio Shack. I see this spring, and I haven't seen him since like probably 93. He's all, I haven't seen him forever. I was looking at stereo. So you still got a good boom system? Oh, hell no. I said that's why I'm in here. I might start it up again. Just have one of the best I've ever heard. Huh?
Get out of Radio Shack to do it anymore.
That's what I heard. They closed down. They're big. Well, I mean, what do you do?
Okay.
Kind of, I don't have my contractor's license
Yeah.
anymore.
So why not let?
I did, heating and cooling is what I do.
It sucks when
I
somebody
don't have
get
my
it.
license, I work for the county. I didn't know what this was all about.
Oh, that's all the Casey's in there. Yeah, there's some basic buildings in town. I mean,
No, I don't. I don't. I get home. I see.
Yeah.
I don't know if it's.
Right. There was amplifier things, they was carry on. A couple of resistors and diodes that I had to use. That was the only place I could find. I went in there since we're 92.
I have been in there since they moved to the. It's right next to the country.
Okay, should we find our seats and wrap it up?
Me neither.
Video movie like whatever.
Okay, as we finish up, I will have your certificates up here. So if you want a certificate, just remind you that you attended the class so you have evidence of it. You're welcome to come grab it.
Wall, office.
Yeah, frame it and hang it up.
2 years. Can we do it again?
Yep. Yep, it's maybe, just maybe, we can get out here and do a class, a shorter class, you know, in the interim, and so next time you accrue it over time rather than a 6 hour, but we'll see. Fireplaces. I know everybody loves a fireplace, but with the way the code is written about air sealing and everything, it's really tough to put a wood-burning fireplace in a house and not be in direct conflict with other parts of the code. And so the codes try to address it by saying we need tight fitting dampers and outdoor air and listed and labeled doors. And it says that a factory built or masonry fireplace shall be equipped with all these things to ensure proper combustion unless the room is mechanically ventilated and controlled so that the indoor pressure is neutral or positive. How do you have a fireplace burning that doesn't take the building or the room negative pressure? It's almost impossible unless you have a makeup air system. That first house that we had, there was 400 homes that were built just the same. It was all the same builder. And what we all learned real quick is when you build a fire, there was a bedroom window that you cracked open, not a bedroom, but a living room window. It was about 5 feet from the fireplace, and you crack it open so it could get air, but it did take the house negative still. That's how it drew air into it. Did you find the guy that you were?
Yep.
Okay, thank you. So, you know, I don't know how many of you guys have done work in the Park City area. Does anybody know where the Colony is? Are those little houses in the Colony? They're huge houses, aren't they? The Colony, there's not a sign out there advertising it, but as you're coming into Park City, you curve past the canyons, and just before that little, I don't know if it's Episcopal church or something like that, there's a turn that goes up. And they have their own little lift that'll run you over to other places, and everything's 10 acres, and how many houses are, they're probably $20 million now. So they're these huge houses, and I worked on a house that was in litigation that the builder had put in 3 isocurrent fireplaces. You know, those ones with the lightweight block, you know, that you put all together. And one of them you can walk into. 6 feet wide, 6 feet high. You can walk in that fireplace. And then he did what on the house? This is a 20-something thousand square foot castle looking house. He spray foamed everywhere. And guess what? The fireplaces didn't work. $100,000+ put into fireplaces and they didn't work. So he put 2 power exhausters on the big one. So I had 2 15-inch fans going up off this massive fireplace, 2 exhaust fans on top of those 15-inch fans. And guess what happened when you turned it on? And it sucked air down all the other fireplaces. Right? And one time they had a fireplace burning before they started the other one.
Oh.
So you really have a problem if you're trying to burn wood inside a house that you're trying to create a tight envelope. It just doesn't work unless you put doors on it and you have an outside source of air. Fire, what we need to have are what we're doing. Do your fire kits outside. Don't try to put them inside your house because it just doesn't work with what we're doing today. Someone have a
I was gonna say, isn't this about the same regulation as, you know, manufactured housing? You gotta bring in air. You can't do anything.
You can't use everything in the house. It's just nuts. It just doesn't work. Yeah, I need to put a picture of that in there. That thing is so huge. I mean, it's a cool house. I mean, it's a completely incredible house. And the sad part is the lady that built it, she was a few years older than me, and her husband had died, and I guess had been quite wealthy. And she got the house finished, moved in after lawsuits and everything like that. And she come to just reality and had to sell the house after 4 years of fighting to get the house right. Which takes us to the next thing. An 80% efficient furnace is what we call a natural draft furnace, or a fan-induced furnace, which means it draws combustion air from the space. A natural draft water heater has a little diverter on it. We have it's like heating a pot on the stove, but we have a opening up the center so the product's combustion can come up, and it comes out here, draws some other air from inside the space and takes it up the vent. A B vent is a natural, non-positive vent system. It relies on stack action, it relies on chimney action to draw the product's combustion up out of the house. And since we're drawing air out of the inside of the house, as I mentioned earlier, and you can't see it, but there's combustion air duct up behind here, we have to bring in some outside air to replace or supply what air is required for the combustion process and what gets drafted out as secondary air on your combustion. And it's drove me crazy forever because it's the same thing as a fireplace, just not quite as bad. We're exhausting air because we're trying to get our product's combustion out. I call that wood fireplace a wood-powered exhaust fan, because that's really what it is. But this is just a natural draft B vent that's drawing air out. And so what the code says, and you can blame me for it and some of my friends from Colorado, because we finally got together and we put it in the code, that if you have this condition with open ducts, open combustion air ducts serving open combustion fuel burning appliances, the open duct, so the combustion air duct and the appliance or appliances need to be enclosed and sealed in an insulated room, isolated from the rest of the envelope. So it's the same thing as a sealed fireplace with combustion air coming into it. We're creating its own separate environment. We bring the air in, we let it go out, and it doesn't impact the rest of the inside of the house. The combustion air duct passing through the conditioned space shall be insulated to a minimum of R8. So we have to build a little room, we have to insulate it to the level of a basement, which would be R15. Has to be sealed all the way around, which is really tough, isn't it, to insulate, to seal around that whole duct system and everything. In fact, it's brutal to think about it. Weather strip door, tight. What's happened all of a sudden, we put the air handler, the furnace, outside the thermal envelope. Now we have to pressure test the duct system because our air handler is not inside the space. We have to insulate the duct because it's outside the space. So you're thinking, well, why in the hell did you propose something in the code that makes us do so much stuff? Because I'd prefer you use the exception. And what is the exception? Direct vent. 90% efficient, power vented, 2-pipe water heaters, all the problems go away. In the 18 code, it says that if you use all direct vent, space heating and water heating appliances, you do not have to provide makeup air for your kitchen range. Because the big reason that was put in the code is because they reversed all the B vents. You eliminate the B vents, we have eliminated the risk. Now, it's still not going to work very well if you put in a 1200 CFM fan and it can't get any air. You're still going to smoke up your kitchen because it can't get 1200 CFM replaced, but we've eliminated the hazard of reversing the B vent. So, now I've had people say, well, you know what, 95% efficient furnaces have more problems than 80s, and I disagree. When 90% furnaces first came out it was about 1980, 1981, they did have some issues. And they've been worked out a long time ago. My experience is sealed combustion appliances have fewer problems than open combustion appliances. Those that do HVAC, if you run both pipes on your 95% efficient furnace, so you're drawing combustion air from outside, not drawn from inside, or direct vent water heaters, how many have flame rod problems like you do with 80% efficient furnaces? I never had problems with my direct vent furnaces. I can't even remember cleaning a flame rod on a direct vent furnace. I've cleaned thousands of flame rods on 80% efficient furnaces. And it's because, why? Because they're burning air out of the inside of the house that has all the chemicals and the hairsprays and the dryer sheets and all the other crap that, whatever, and the outgassing from the carpets and everything else that contaminate the flame rod that you have to clean on your 80% efficient furnaces. So, to solve it, don't go through all that bother of doing all that stuff by putting in direct vent appliances. The furnace is the easier part. The water heaters tend to add a little bit more, but we have a lot of products out there, and yeah, it's going to cost you $400 or $500 more. Or if you do tankless, it might cost you $1,000 more. But it takes care of the problem. I love my tankless water heater. How many have tankless water heaters? Nice. I mean, yeah, there's a few things you got to get used to, but boy, you can.
I'll never go back.
You don't run out of hot water. Recessed lighting, we already talked a little bit about it. It needs to be an airlock or airtight can, and it needs to have a gasket. We had the question earlier on, can you res check your way out of a poor window? The maximum U factors and solar heat gain coefficients for windows is 0.48 for climate zone 5, and it's 0.40 for you guys in climate zone 6. Now that is an area weighted average. So if you had 1 or 2 windows that were higher than 0.4, if you took all the windows and did an area weighted average, and it comes out at 0.4 or lower, then you can still put those in. And if you have a question on area weighted, send me an email, and I have a couple of slides that go through it. That basically is you account for how much area do you have at each U factor. So duct leakage, this is the one that we needed to make sure we talked about. And very similar to blower door testing the house, but we're blower door testing, or duct blaster testing is another way we refer to it, our duct system to ensure that it doesn't leak too much. What does the red text mean? That means our legislature allows double the leakage that the code does. But it is what it is. Pressurize the duct system only to 25 pascals, half as much as we do our house, and then measure the leakage. And in this case, they just temporarily tape the panel on the blower door of the furnace, mask over all the registers and grills, and pressurize the duct system and see how much it leaks. If you have ducts outside the thermal envelope, you have to do this. If you're if they're inside the thermal envelope, you don't have to. And I'm not going to read through all this because I just mentioned it to you. We started out when we first had this state amendment that if you have 50% of the duct inside the envelope, 50% or more outside the envelope, you had to test. And what we've got up to now is you can only have 20% or 80% has to be inside the envelope before you have to test. So you can only have less than 20% outside the envelope. So you might be able to run some runs to a bonus room or something like that and not have to test, but it's very rare. And then there has to be a written report.
Let's see, before we go too far, back up one more slide.
Okay.
Cavities. We were talking about making return airs out of ductwork, but I think that hasn't gone through yet, correct?
Right. So with all this duct testing, the code without amendment says if you're supposed to test it all. But if you're going to test all your ductwork, you can't pan joist because you'll never pass a test. Ever. I mean, I went on one, we tried to, it was a nice house and the HVAC system looked pretty good. We didn't have enough horsepower in the fan to get the duct system 25 pascals because all the wires and all the eye joists are hard to seal up. And, but the legislature has amended the code and said you can't use building cavities as plenums or pan joists and stuff. But it's been amended so you can use them. But if you have to test, say you put a furnace in a closet on the top floor of a 2-story, run all your ductwork, supply ductwork in the attic, and your return comes in the bottom through some ductwork, you know, or some panning and stuff on the main level ceiling or that, you know, second floor, you're not going to pass the duct test, the duct pressure test, if you have panel on joists, but unless you went to a lot of effort to seal it up. So by amendment, we can still pan joist. Now I know some HVAC people that quite a while ago, they just decided they'd duct everything because the panning is sometimes a bigger pain than, you know what I mean? And they just run 8-inch pipes with 4x14 boots, you know, and stuff them up in the walls at all their returns and just duct it all. It's easier to seal and does a better job. Yeah, I kind of skipped over that, didn't I? Can you see that dovetail? You can almost stick your finger in that hole there. Now they smeared the crap on it. I kind of struggled with this, and maybe I was obsessive compulsive or whatever, but how do they typically cut the holes in the duct? Do they cut it after they put up the duct, or do they cut it while it's still on the ground? I always cut them before I put it up, didn't you? You measure out where your holes are gonna be, you mark them, you cut them all out. Put your takeoffs in, put the duct on. Because it's a pain to get up there and try to cut them, and it's a pain to get up there and try to put the dovetails in. So what we did is we cut them out, and then my guys had caulk guns with sealer, and we sealed them all as we put them in the duct. And so the only thing we had to seal were some of our cleat joints and stuff like that after the duct system went in. And some of those we even sealed as we were putting together. Before we bent our drives over, we put some sealer there and stuff like that, and seal them up. Getting up there after and trying to smear all that crap all over the place, and you need a lot of sealer to seal up a poor dovetail like that. So that's just the lack of craftsmanship. That's all that is. We already talked about duct insulation, so I'm not going to beat that one up anymore. This guy actually got mad at me, told me I was being nitpicky when I turned him down on inspection because he didn't seal his ducts. If you have central air conditioning and you have a basement, is your basement typically cold in the summer? Part of that is because the duct's leaking, and 15 or 20% of the air that you want to go upstairs is going into your basement because of this kind of stuff. We want our duct tight, even if it's inside the envelope, because we want it where we designed it to go. We want it in the master bedroom or the other bedroom or the game room or whatever. We don't want it in the floor joist. I've beat this one up pretty good. Here's an air handler, a furnace in an attic, suspended above the insulation level, and then all the ductwork off it runs above the insulation. This was in St. George. All the sheet metal needs duct insulation. The thing that really kills me about this one is it didn't have a platform. Anybody that's an HVAC guy that's worked on a furnace in an attic knows that that's the stupidest thing in the world to not have a platform, because talking about building science, there's something about, you know, we talk about black holes in space and something. If you drop a 5/16 socket in 18 inches of insulation, are you going to find it? You drop a small tool, it's gone. You can dig around in that crap forever and you can never find it. I had that much flexibility on letting people get by without platforms and catwalks on equipment in attics because it's such a pain to service, and it doesn't get serviced if there's not access to it. If you just have the air handler outside the thermal envelope, you have to test the system. If all your duct is inside of the air handler, if you put your furnace in the garage, you should be testing the whole system because your air handler is not inside the thermal envelope. Now, the way you can get away with it is if you define your thermal envelope to go around the furnace room and put it in the house. Does that make sense?
So what if you build a tight fitting room and insulate it, that's actually be part of the envelope, you know, put a tight fitting door, insulated the walls, it might have a different wall, you know, to the house, but that would be the same.
Yeah, if you kind of create it so it's part of the envelope, but then it better be direct vent. Right?
Right.
Because of our previous discussion. Boy, these pictures just aren't coming through very good, but this was one we did in St. George. And they're doing some pressure testing when at rough stage before there's any drywall. I need to fiddle with the contrast on those. The leakage requirement, as amended, if you have 2,000 square feet of conditioned space, you can leak 160 CFM. Now, do you really want to throw away 160 CFM of air that you just spent money to keep it cool? I don't think I do. some more pictures. We're gonna make it, guys, because most of the rest of them are just pictures that we're gonna talk briefly about. I'm gonna cut another two more cuts more lights. Is that a little better? We're having the same thing. We have ducktails that are just not tightly fitting, that are leaking really bad here. Yeah, I've actually called a couple of contractors and said, hey, let's meet, let's talk about these. And we took pictures and stuff like that. And I've asked them, fix it and take me some pictures, send them to me, because there's no excuse for these. Now the code did say, and it's since been changed in the 18 code, so it's up to you if you want to accept it, because we didn't adopt the 18. But the 15 code says all your longitudinal seams on any snap lock duct has to be sealed. So that would be the whole snap lock seam, top and bottom. And where else? What else is snap lock? Round pipe. I think that was ridiculous because you just. Huh?
About Pittsburgh.
No, Pittsburgh, you don't. Anything that's snap lock. Now I can see if your lock former machine for your snap lock is not adjusted right, it's a pretty sloppy joint. And yeah, I can see that would leak a little bit, but 6-inch pipe or whatever, when you snap it together, it's not leaking. And so actually that got stuck in the code, and then a bunch of us pushed to get it out, because if it's inside the envelope, why would we, it's just the leakage is minuscule compared to all the other places. Now for inspectors, you don't have to have a ladder, because you can get you a little mirror, telescoping mirror, and you can just stick it up there and see if they just smeared the 3 sides you can see and not see the top. This was in a really nice house, and this is a corner of the duct. The drive cleat, they kind of drove up part way. Would you be pleased if your employee did that? That's terrible, isn't it? You think that leaks? That leaks quite a bit. Selective duct sealing. They seal, these are all the same house. They didn't seal this, they didn't seal this, they did seal this, and they did seal that. However, some of these, it looks like they've sealed what looks like big leaks and not sealed others. And guess why? Because they did spray and duct seal. Has anybody seen that, where they open up the duct and they spray a mist in there, they pressurize the duct, and it seals internally. They block it off so you don't get it on the coil and you don't get it in the furnace. But they pressurize and spray a latex sealer in there, and it seals the duct. And in fact, they call it aero. I'm trying to remember.
AeroSeal.
Well, the AeroSeal is this one AeroSeal, or is the one that they do the whole house? Has anybody seen them do the whole house after drywall?
Is this like for floor doors? Yes, they spray it all in the house.
Well, they mask the windows so you don't seal them, but they set up these little tripods with these little misters, and then they pressurize the house to 75 pascals. Aero barrier. I think it's aero barrier. It's AeroSeal for the ducts and aero barrier for the house. So they spray this mist into the air with the house pressurized. So what does it do? It pushes to all the leaks, and it'll fill a hole as big as a 1/2 inch. It'll cost you some money. I think it costs you $1,000 or so to do it, but they can show a house going from 6 air changes per hour down to 1 air change per hour just over time as they run that sealant.
I would assume that this is when it's in drywall and not finished, and
Yeah, yeah. You can do it as soon as you drywall, or you can do it as soon as you put your lids in. You can do it as soon as your lids are in. But if you're spraying the sealer in the duct, and it's a similar system, you seal the big ones, and then they spray it in, and it's kind of like putting, there's guys with hair the color of mine. Dean, you ever seen people put oatmeal on a radiator to stop the leaks?
I've heard of it.
Yeah, or leak stop stuff. What's the green slime that you put in a tire that has a leak? It's the same type of process. We're trying to push a sealer into our leaks.
Oh, nice.
These leak just as much as the crimps, just about. This guy did a good job. He sealed and this one is when they ducted their returns. You see they have a sheet metal boot coming up, and then they've sealed that up. And this is the one where they sealed internally. I walked down in there and I said, wait a minute, I don't see any duct sealer. And then they had a sticker on the furnace. Right here. Airlock, that's what they called it. Airlock duct sealing. And it's an aerosol sealing. And it started out, when they started, it was at 400 CFM was the leakage. And then over time, it got down to was about 35 CFM of leakage. The same thing that happens when they do a house, except they have to run more material. So it started out with an 80 square inch hole, equivalent of an 80 square inch hole in the duct, and ended up with a 5 square inch hole in the duct. Now I don't think I put this in here. Being in, are we in Uinta County? I'm sure we're around people that turn wrenches themselves, and if your lawnmower doesn't work, you fix it yourself. And some of you guys have worked on your car engines and everything, right? Has anybody ever took a lawnmower engine apart, or the engine on a car, and bolted it all together, and then took Permatex gasket sealer and smeared it all over the outside of the engine to stop the leaks? What do? We put gaskets and we put sealers in, we put RTV, and then we bolt the mating surfaces together and we seal the leaks. Lots of leaks in duct systems are at the furnace, where the return or air filter cabinet hooks onto it, where a coil cabinet goes on top of the furnace, where the plenum flange mates on top of on the coil cabinet or the furnace. And why we don't put down a bead of sealer on those mating surfaces as we're putting them together, rather we try to smear the crap around the outside of it and hope it holds. You know, it's kind of beyond me. It's kind of like a plumber trying to seal a leak in his ABS. You know, he fills it up with water and it's leaking, and you might have seen him try to smear glue on it from the outside to shove it in the little leak. And then after he works at it for a while, he gets pissed off when he cuts the fitting out and glues a new fitting in, because you don't seal well from outside. What I'm trying to say is, for HVAC people, you're going to have a lot tighter duct systems if you put sealer down as you're putting it together. It's going to work much, much better. So here are the places that they really leak. Where your coil cabinets, number one, the holes in your coil cabinets where your drains and everything come through, where you hook it down onto the furnace all the way around, where your filter cabinet hooks onto the side of the furnace, where the drop hooks on the side of the filter cabinet, and the bottom of the furnace. In years past, I think most of them were sealed better in the bottom. But these are your big sources of a lot of leakage, and they can be taken care of simply with a little bit of effort, and it looks a lot better than smearing the crap all over your coil cabinet and your furnace. The drain hole and your line set holes really leak a lot, and those need to be sealed. Now, I want to say a little bit about direct vent furnaces. Number one, I don't know about you guys are HVAC contractors or your competitors, but we sure see a lot of them in the Wasatch Front that only want to run one pipe on their 95% efficient furnaces. And they run a combustion air in for a bigger combustion air, obviously a bigger pipe size for the code, which doesn't make any sense to me because I think it's easier to run a small 2 or 3 inch PVC than it is to run a 7 or 8 inch pipe and put a grill and everything on it. But it's a much better system because then it's direct vent. If you do not run both pipes, it is not direct vent and it doesn't fit the definition of direct vent in other parts of the code. So we have to run both pipes to call it sealed. And the furnace has to have a sealed burner. Now this furnace here has a sealed burner compartment. And this is a newer Linkage furnace and they still have the sealed burner compartment. And they're not relying on the upper door to seal the burners. Where if we go to a lot of furnaces nowadays, rather than the sealed burner compartment, you can see the burners right there. And we have to rely on the door and a gasket. But what's the other critical thing? All the penetrations into that upper compartment have to be sealed. So we have to make sure that if our furnace, and this is installation instructions, if the upper compartment does not have a sealed burner like this and this, and I know that's a little hard to see, but that's the burner manifold right there and the burner's going in. Here's our combustion air coming in, our vent going out. We have to have the grommet that comes through with the furnace on the gas line, and any knockouts or anything have to be sealed. Otherwise, it's not direct vent. It's not sealed combustion. Mechanical ventilation, we've already talked about it. If you're tighter or equal to 3 air changes per hour, 50 pascals, you must mechanically ventilate. If you choose to blower door test, you're going to have to hit 3.5. There's a good chance you're going to be below 3 or 3 or below. Just mechanically ventilate. In fact, I suggest that you decide just to mechanically ventilate everything you build. For more information, get a hold of me. This is kind of repeating what we already talked about. We have supply, exhaust, or a combination for balanced. Here's one of these super quiet fans. And we have a little timer here that times it off. We have our CFM selection, and they are very, very efficient, and they don't make any noise. They're really great fans. I probably ought to get one and just bring it with me and set it up during class, and you won't even know it's running. And here's our efficiency chart. They have to have an efficacy of no more than, it has to be, this is maximum. It has to, like a bath fan, 2.8 CFM per watt or better. This is in the 2018 code, but we actually adopted it by amendment. So a couple of final thoughts, and we are going to make it. We wrap a house with an air barrier. They missed the rim joist. They do the outside of the garage, but they didn't do the wall inside separating the garage from the house. Can a building be too tight? Not if we ventilate it right. I know that's the easy way to insulate the rim joist, but it doesn't work. And it's really poorly fit. It's not cut to fit. We've seen these pictures. This is a real important area to address. Here's a cantilever, kind of like I had in my house. They have a heat run going out there. What's the chance that the rim joist out there on that bay has insulation running around on the rim? Almost nothing, right? So if we close this in, We basically have an uninsulated rim joist down at the other end, all the way around that whole cantilever. And with the open air spaces, we really aren't insulating the duct. And we have to make sure we seal the underside.
What else?
I'm sorry?
And what else? You go back to that heating design, which they shouldn't do. Gotta cut a hole where that's cantilevered and that eye joist there, rather than knocking it out, put it through there, because that's supposed to have that spacer right there.
It's supposed to have locking on bearing, isn't it?
Yes. It is. I mean, they put two befores up the side, but this is very common in heating, where you just knock that out, and nothing happens.
Like you get boot through it, pretty round hole.
Cut a hole.
How
No,
do you get a 4 to 10 foot in a 6-inch round hole?
you're going outside and put it up.
Or if they got an OSB on the bottom?
Well, if you got OSP, I mean, it's something you're gonna have to work out, and you make a good point.
Right. It's just something we see out of it.
Yeah, you do. And you know what? I know we like to get them back at the window. If that was super insulated, like if they dent and blew all the cantilevers and sealed, you know, we had air barriers, we had rims, joist sprayed, you could leave them out on either side of the bay. And it's gonna be just as comfortable because you have a well-insulated bay. It's not gonna be a cold bay. I mean, there's options.
And the wood doesn't keep it warm, it's actually for rolling.
It's for, yes, for the rolling of the joists. And yeah, you can just put a 2x4 up there and a 2x4 down there. I mean, it's a weak spot. There's no question it's a weak spot, and we need to be mindful of it and see how we can work through that. This is, I had a picture of this furnace, and you can see it back there behind. This is in St. George. They built the whole house with scissor trusses, and you can see them going over the whole house. And then they did all these drops. This is drop right here is over the laundry room. They literally could have put the furnace in this cavity right here, put a lid in it. They had drops that ran around here. They did drops. The entry, you see the drop here, the drop ran around. They could hit the whole house with ductwork underneath the attic, except for one supply. And all they would have to do is a little soffit above the kitchen cabinets, and they could get it got out of there. Everything would have been inside the envelope with existing drops except for the one. Put an access in the laundry room, you jump up, your furnace is there. It's been beautiful. But every house they built like this has 100 to 200 higher electric bill every month in the summertime because it's all up in the hot attic. Here's, they put air barrier up for low insulation. You like this? I went to do follow-up inspection and no one had called this flex crushed by the plumbing. We're gonna have to communicate a little bit, you know, amongst the subs and the builder, and gonna have to anticipate some of these problems. I don't know what they thought they were doing here, do you? How much can you crush a flex duct per the manufacturer? 0. That was nice. How tight could you bend it? The radius of the duct needs to be the radius of your bend or bigger. No kinking. Here's this return that they've got with the return. Here's the high heel truss they put a baffle on. Probably could cut a better hole than that. I like they're doing a flashing or something out here to try to make that penetration through the cladding a little bit better. That's what we're overcutting the holes. Something needs to be done to seal them. Pipe supported by the water line. You HVAC people, Could you put a termination on that if they come in and stucco it just like it is? No, because the termination requires a certain amount of space between the two pipes. So they come in and stucco it, and what do? They come in and beat the stucco apart so they can get the termination on it. All this stuff in the air barrier, and I was guilty of this as an HVAC guy. I didn't think much about it back in the 70s and 80s and 90s. You drill a hole in the outside through a brick or the cladding or something, you sealed it on the outside, but you didn't seal it all the way in where you penetrated the air barrier. Getting building paper behind these where you need to, and if it doesn't operate 24/7, you have to have a backdraft damper. Positive items on this one: insulation dam all the way around with a high deal, intersecting walls. Where you come in, it's hard to tell, but you can get the insulation all the way around it and behind it. The extra space in the headers is insulated, and they actually spray continuous foam on the exterior of this one. Garage wall needed an insulation dam. The insulation markers, those are rulers, those are a great idea. Is there an air barrier behind this soffit material? Return path from every bedroom. Does it say that in the code? What it says is follow Manual D. And what does Manual D say? Manual D said you have a low resistance path from every supply to a return. So if you don't have a return in bedrooms, you need to have transfer drills or something to get the air out. You can draw a little bit under a door, but only one 6-inch run can draw under a door if it's undercut an inch and a quarter. Manufacturer requires installation instructions on the site. Air barrier needs to be behind fireplaces and tubs, and we made it. Any questions, comments? Feel free, if you have a comment or question, to reach out to me. Otherwise, we'll see you another time. I have certificates here. I'm going to just spread them out right here rather than read out names, and you can come grab them. Thank you.